on to problem 1.29. So here we are asked to verify that sine theta is equal to e to the power I theta minus e to the power negative I theta divided by 2I, and cos theta is equal to e to the power I theta plus e to the power negative I theta divided by 2. So we need to verify that the left-hand side and the right-hand side of these two equations are equal. So let's start with the right-hand side of sine theta equation, which is e to the power I theta minus e to the power negative I theta over 2I. Now, we know that e to the power I theta can be written as cos theta plus I sine theta. In a similar way, e to the power negative I theta can be written as cos theta minus I sine theta. Now we are dividing everything by 2I. So this would be, we're going to have cos theta minus cos theta gets canceled. And we have I sine theta, minus of minus becomes plus I sine theta divided by 2I. Now I'm going to cancel out I from everywhere. And this will give me 2 sine theta over 2. And I'm going to cancel out the 2 to give me sine theta, which is equal to the left-hand side of the equation. So we proved that the right-hand side of the equation equals the left-hand side. So we have verified that. Now let's work with part 2, which deals with cos theta. And the right-hand side of the equation is e to the power I theta plus e to the power negative I theta divided by 2. Now let's expand e to the power I theta plus we have a cos theta minus I sine theta divided by 2. Now I can cancel out I sine theta and negative I sine theta. So this gives me 2 cos theta over 2. I can cancel out the 2 to give me cos theta, which is equal to the right-hand side of the, which is equal to the left-hand side of the equation. Hence, we have verified that sine theta and cos theta are actually equal to a linear combination of e to the power I theta and e to the power negative I theta.